Welcome to qnawire.
Okay, which of the following can adopt a chair with no axial methyl groups? Okay, so we've got cis-1,2 dimethyl cyclohexane. I'm just going to draw a chair. Okay, and we're going to call this carbon 1 each time. Okay, so cis-1,2, right? So let's maybe make it equatorial for our first methyl group. Cis-1,2 means that if the methyl group here is equatorial, then this one, if it's on the same side of the ring, will actually have to be axial, right? Equatorial, cis, axial, right? So if I do the chair flip, this will go to axial and this will go to equatorial, but we'll still have axial substituent, right? So that's not going to work. Let's look at 1,1-dimethyl cyclohexane. Well, I think that one should be pretty obvious that it won't work, but let's see why. Okay, this is carbon 1. Well, on any given carbon, one substituent has to be axial and the other has to be equatorial. And if both of these are methyls, then no matter what we do, we'll always have one of them axial, right? Because if we do a chair flip, this one will go equatorial, but this one will go axial, right? So that's not going to work. Next, we've got trans 1,3-dimethyl cyclohexane. So let's draw a chair. Okay, call this carbon 1. And so then this is carbon 3, and it's trans. All right, so let's start by drawing an equatorial methyl group and an axial hydrogen. And then we go 1, 2, 3, okay, and trans. Okay, so we know where there's going to be two groups, one axial, one equatorial. And if this thing is trans to the methyl group, then that means it has to be the higher of the two, right? This one's on the bottom. So this one must be on the top, meaning the hydrogen's down here and the methyl's pointing up. And yep, that's not going to work because even if we do the chair flip, then this equatorial will go axial. Even though this axial will go equatorial, we'll still have an axial when we do the chair flip. So that's no good. Let's look at the last one. Trans 1,2 dimethyl. Okay, so carbon 1, carbon 2. Let's do axial, equatorial. And, we're going to make the hydrogen axial because we're looking for a version where everything's equatorial. And so if it's trans 1,2, that means we've got a methyl somewhere on carbon 2, and we know that carbon 2 should have an equatorial substituent and an axial. And if the methyl group has to be trans to the methyl group on carbon 1, then that means it has to be the higher of the two, which means this has to be the hydrogen, the lower of the two. And hey, look, these are both equatorial. So this one will work. The answer is trans 1,2 dimethyl cyclohexane.